Now in this lecture we are going to create a stack using array over here. Now the first thing that I'm going to do, I'm going to create stack class over here. So I'm going to add new file. So the name of file will be stack.java. So inside this file I'm going to create our stack class over here. So the class will be like this, public class stack. So in our stack, the first thing that we are going to do, we are going to create an array of integer. Then we are going to create another variable which will be the top of the stack. So in this variable we are going to save the index of top element. So that's why the first thing that I'm going to do, I'm going to declare int array like this. Then I'm going to declare variable top of stack with the type of integer like this. So inside this class, the first thing that we are going to do, we are going to initialize the array with fixed size. Then we are going to set the top of the stack to -1. So if we don't have any element in our stack, so this means that top of the stack will be -1. So here I'm going to write stack, and it will take as a parameter size, integer size. Now this will be the set to the array with the size of integer. So this will initialize this array with this size that we are giving over here. So it's going to be like this, integer size. Then we are going to set this top of stack to -1. So I'm going to put it like this, top of stack -1, because in this case we don't have any element in our stack. Then I'm going to print out to the console saying that the stack successfully created with the size of this size that we give over here. So the message will be like this, system out print the stack is created with size of size. So with this we have successfully implemented creation of stack in our stack class. Now let's see how this is working in practice. So here I'm going to create inside main class the instance of stack. So here it's going to be like this, stack new stack will be new stack with the size of, for example, 4. Now if we run our code, you will see that it prints out to the console saying that the stack is created. So here you see that the stack is created with the size of 4 over here. Now with this we have successfully created our stack over here. Now let's see what's the time and space complexity for creation of stack using this array over here. Now as always we are going to start from the first line of code. So in the first line of code we are initializing array with this fixed size, and this will take one time complexity. Then we are setting top of stack to -1, and this will also take one time complexity, and then we are printing out to the console message saying that the stack is created successfully. And this will also take one time complexity. Now if we combine all these complexities over here, it will take one time complexity. Now the space complexity is on, where n is the size of the stack. So if we created a stack n, it means that it's going to allocate contiguous n number of cells in the memory. So this means that it will take on space complexity. So creation of stack using array will take on space complexity. So with this we have successfully implemented a stack using array over here. Now the next method that we are going to implement is isEmpty method. So under this method over here I'm going to write isEmpty method. So isEmpty method, we know that will return boolean value. So it's going to check that if our stack is empty, it's going to return true, otherwise it's going to return false. So I'm going to declare our method over here. So I'm going to just comment over here, put isEmpty. So here our method will be like this, public boolean is empty. So it's not going to take any parameter because we are going to run it for this stack over here. Then inside this method, the first thing that we are going to do, we are going to check top of this stack over here. So as you remember, when we are creating top of stack, we said that if the top of stack is equal to -1, this means that our stack is empty, otherwise it is not empty. So here I'm going to use this top of stack over here and comparing it with -1 to see that if it is equal to -1 or not. So the if condition will be like this, if top of stack is equal to -1, it means that our stack is empty, so I'm going to return true, otherwise we are going to return false. So as you see, the implementation is very easy over here. So based on this top of stack we can identify that if the stack is empty or not. Now let's check how this is working in practice. So as you remember, we have created our stack over here. So we know that this stack is empty now. So if I call isEmpty method, it should return true. So I'm going to create a boolean value over here and put it result, and then I'm going to call isEmpty method. So in this case, it should return true. So if I call isEmpty and then printing out this result to the console, so I'm going to put it like this, result to the console, it should print out to the console true. So if I run our code, now you see that first it's printing out to the console saying that the stack is created with the size of 4, then it returns true. So this means that our stack is empty now. Now let's see what's the time and space complexity for this method over here. So it can be easily seen that the time complexity is 0.1 because in this case we are just checking the top of stack and returning true or false, and these operations over here will take 0.1 time complexity. So the time complexity for isEmpty method in this case will take 0.1 time complexity. Now the space complexity is also 0.1 because in this case we have not performed any operation that is space consuming. So isEmpty method in stack using array will take 0.1 time complexity, and also it will take 0.1 space complexity. Now let's continue to the implementation of next method. Now in this case the next method will be isFull method. Now here I'm going to comment isFull and declare our method over here. Now this method also will return boolean value, so that's why I'm going to put it like this, public boolean isFull. So this method will not take any parameter. Now inside this method, the first thing that I'm going to do, I'm going to check top of stack with the length of array that we declared over here. If the top of stack is equal to the array length -1, then in this case this stack is full, otherwise it's not full. So we can return false in this case. So if condition will be like this, if top of stack is equal to array length -1, in this case our array is full, so I'm going to print out to the console saying that the stack is full, the stack is full, and if it is full we are going to return true in this case, and otherwise if it is not full we are going to return false. Now with this we have completed this isFull method also. So as you can see, this is also very easy in case of array over here. Here also we are just checking it based on top of stack and array length over here. Now let's see how this is working in practice. So here again, instead of isEmpty method over here, I'm going to call isFull method. Now in this case it should return false because in this case we don't have any element in our stack over here. So this means that our stack is not full, so it's going to return false in this case. So as you can see, after creation it returns false over here. Now with this we have implemented isFull method also. Now the time and space complexity for isFull method also is 0.1 because in this case we are just comparing the length of the array with the top of stack, and we are printing out to the console this message, or we are returning true or false. So these operations over here is not time consuming, so this will take 0.1 time complexity. Now the space complexity is also 0.1 because in this case an extra memory is not required to perform these operations over here. Now with this we have performed 3 main methods of the stack, in which we are creating stack over here, and we are checking that if this stack is full or not, and we are checking that if this stack is empty or not. Now to make our lectures shorter, I'm going to implement the other methods in the next lecture. So see you in the next lecture.